Hi everyone, it's nice you are joining for this video. Today we are going to present an algorithm that detects price movement channels, and we will write this in Python. You can download the code as a Jupyter notebook file from the link in the description below. This idea was proposed by someone from the comments section, Mr. or Mrs. M, whoever you are. Thank you for your patience. It's probably been more than a month of waiting, and I hope this video won't disappoint. Just to be clear for new members, the purpose of this channel is educational, and so the idea is not to provide programs that you would download and just use as black box for whatever purpose, but rather to explain the process of thinking and how the program was built. So by the end of this video, you would be able to build your own algorithm, maybe somehow inspired by the one in this video, and to add extensions that were not introduced in here. I mean, you are probably watching this, but at the same time, you have your own trading logic that you would like to implement. Ideally, following my videos would provide you a good starting point. And to avoid any kind of frustration, there is something that we should know before starting this program. This topic is still an open field of studies, meaning that we can still find relatively recent studies in academic and research publications that are trying to find the perfect way to deal with price trends and predictions. So in other words, it's not that simple for some of the reasons that we are going to discuss in our program, and mostly it's because the market is very dynamic. We can't stick with a set of variables, just count that it's going to work fine for the rest of the future. Things tend to change during time, trends will change, and the speed at which the trends will change will also be changing at the same time. So it's a very non-linear and dynamic world that you are trying to predict. So just accept the limitations of numerical models when applied to such an environment. So the algorithm I'm presenting here is totally home imagined, based on simple information gathered so far through this channel. And now we can start and get creative. So the way we are doing this is by positioning ourselves at a certain candle or a certain date. So looking back in time for a certain number of candles, we can take, for example, like 30 days or 30 hours if you are working with the hourly charts or anything else. We can count for a certain number of candles. Then we are going to divide this time into equal parts. And in each part, in each window or time window, we are going to find the maxima and the minima, which are the highest and the lowest points the price will be touching. So we are going to do this for all the equal windows of time. And then we take all the minimas and we fit those into a polynomial or linear fit that goes almost across all those points. Then we do the same for the maxima. So now we have two slopes describing the trends of the minima points and the maxima points. Notice that these slopes are of the first degree, meaning we're not dealing with curves, but rather with straight lines. And you may also notice that these two slopes don't really wrap around the price because they go through the points. This is the way the polynomial fit is working. So in order to adjust this, we are going to improve the intercept value of those slopes. And here we have many different ways of doing so. We can, for example, fit those slopes to go through the minimum point that is the closest to the middle of this big section, big time section that we considered. So for example, this slope here would go to this minima, to go through this minima, and this one would go to this maxima, which is the closest to the middle value of this time section. Or for example, I will modify the intercept so that these two curves will go simply through the highest points and the lowest points that could be found, meaning the highest maxima and the lowest minima that we could find in this big time window. Another question is, how long should this big time window be? For example, should I take 30 bars, 40 bars, or 60 bars behind the present bar of interest? And this is going to change the slopes and therefore the results of my trend channels. So in order to deal with this, we are going to allow the program to take different values in a for loop. However, these values will be limited by the user's input. For example, we are going to take 30 bars behind this particular candle, plus or minus 20 bars. So 30 and 20 are two values of two different variables that we are going to modify before each program. But then the program will roam around 30 minus 20, for example, 50 bars, up to 30 plus 20. So it's going to be 10 bars behind this particular candle. It will check the slopes that we are finding for each number of bars and will only return the number that provides the most parallel situation between these two slopes, because this is the most probable situation where we are detecting a channel. And this is why we will see that most of our results will show parallel slopes and also different number of candles that are taken into account. So this is our Jupyter notebook file that you can download from the link in the description of this video. We are starting by importing pandas. We're going to use a data frame, and then we load the data frame using the read_CSV, copying the content of this CSV file. So here I took a euro versus dollar file with 4 hours candlesticks going from 2003 up to 2021. The names of the columns are time, open value, high, low, close value, and the volume that we are not going to use in this program. Then I will try to check if we have zero volume days or zero volume bars, where probably the market was closed or we didn't have any trades for some reason, or we simply don't have a data for that particular moment. And we are erasing these because they are of no interest for us. And then we reset the index of our data frame since we have erased some of its rows. And that's basically it. We have just loaded our data, just printing the first 10 lines. We can check what is the data made of. Then I can visualize this. I have the habit of checking things visually just to make sure that it makes sense. So we have everything working so far. So now we can start by searching for the maxima and the minima within the time window defined by the back candles variable. In other words, here we are going to check for the maxima and the minima points within 60 candles before the candle ID, which is the present candle I'm interested in. So I'm at candle number 8800 and I'm looking 60 candles before this candle just to check where I can find maxima points and minima points that we are going to store in those NumPy arrays. So it's called maxim and minim. And the indexes of the positions where we found the maxima and the minima points are stored into the XX minimum and the XX max, also two NumPy arrays. So the way we are looking for the maximums and the minimums is by slicing the back candle's big window of candles into small windows. In other words, I'm considering 60 candles just before my candle of interest, and I'm dividing this interval into equal parts or parts of equal width, which is 5 candles each. Obviously, these are user-defined variables, so you might want to experiment on these, changing the number of back candles and the width of the slicing window. You might, for example, use, I would say, 100 candles and, for example, divide these into windows of 10 candles each, into which we are looking for the maxima and the minima points that we are going to store into these two arrays, and which positions will be stored into these arrays. Then for I in range between the candle ID minus the back candles, so we are starting from the first candle up to the candle ID +1, so we can include the present candle into our computation, and with a step equal to the width of the window, we're going to append into the minimum array these values defined here. So it's going to be the column of the low variables, of the low values of the candlesticks. We're going to locate something between I and I plus window. So we are within the window, within the slice we are working on, and we want to extract the minimum value that we can find in this particular slice. And we append this into the minimum array. Same thing, we are going to check the index where we found this minimum. And this is why we're using the index minimum here. And we're going to append this value into the XX minimum array. Same thing for the maximum points. So we are appending the maximum points into the maximum array. Notice that we are looking here for the high column, the high variables column, and then we are looking for the maximum among these. And then we use also the index max to extract the index of the maximum value that we are going to append also into the XX max array. So now I have different arrays that I can use, and I'm going to use the NumPy polyfit function. I'm going to feed it with the indexes of the minimum values and the minimum values, and the polynomial degree into which I would like to fit these values. Here I'm using 1 because we need a straight slope. We don't want to go into curves or something more complicated. And the results, the return values of this particular function will be the slope and the intercept. And I'm storing those into slope of the minimas and the intercept of the minimas. Same thing for the maximas. We're using both arrays, xx max and the maxim. Same thing, we have a slope of first degree. We have a first degree polynomial fit, so it's going into a straight slope, and the results are stored into these two variables. Now we can try and plot these slopes to see how things are working. I'm going to plot up to the candle ID plus, let's say, the back candles value, and starting from the candle ID minus the back candles value. So these were already imported previously, so we don't need these. This is our candlestick plotting, and I'm going to add to the figure the slopes that we have just defined here. So it's going to be x is equal to the xx minimums, and the y is equal to the slope of the minimums times the xx minimums plus the intercept of these minimums. So the mode is lines, and we're going to call this the minimum slope. Same thing for the maximum slope. And if we run this, we get something like this. As you can see, we are not really fitting the prices into these into a channel, but we have a correct fit somehow. We have minimums that are fit into a slope, and the maximums are also fit into a slope. The problem here is that we are trying to fit too many candles at once. So if I try to decrease this number, which is 100 here, let's say, let's take 50, and the window I'm going to take 5. And if we run this again, we have a better result, as you can see. Still, we haven't adjusted the intercepts. We have more work to do. And as we have mentioned earlier in this video, there are different ways of doing so, depending on how you want to build your strategy. Now, one way is to fit the intercepts to meet the highest and the lowest candle points in the time slice that we are taking into account. In other words, I'm checking all the back candles, taking the highest high and the lowest low, and I'm fitting my slopes to go through these particular points. The way we are doing this is by defining a new adjusted intercept for the minimums and another one for the maximums. And we're going to calculate the difference between the minimum low that we can find in a particular slice and what is given by the slope that we have just calculated. So at that particular point where we have our minimum, what is the distance between this point, this minimum point, and our fitting slope? And this difference is going to be our intercept. We add this adjusted intercept to our slope equation, then our slope will be going through this particular point, which is the minimum, and it's the maximum in the case of the maximum. So we do the same procedure for also modifying the adjusted intercept of the maximas. And this is what we get by using this procedure. Now let's see if it's working properly. This is our minima slope. And we can see that it's going through the minimum point that we have among our back candles. So if we're taking all of these back candles, the lowest point in this picture here is particularly this one here. So using what we have just described, we are forcing the slope to go through this particular point. And then the maximum point is probably this one or something here. Well, it's this one. So we are forcing this green slope to go through this point here. And as you can see, it's not as proper as we would like to have. So we are going to try something different. Let's try to fit the intercepts so that our slopes would wrap the price candles. I mean, they would be higher than the highest point and lower than the lowest point. And the way to do this is by defining our adjusted intercept of the maximas and the minimas. That would be equal to the maximum distance that we can find between the slope and the lowest or the highest points. In other words, if I find that this red curve here, this red slope, is higher than most of the lows of the low prices, I'm going to check what is the maximum distance between those low prices and this slope. And it's probably visually we can estimate it to be somewhere here, but we're going to look for this numerically. And this will be our intercept. I'm going to modify my intercept so that this red slope here, I would slide it down so it goes through the minimum point of all of these. So we're not really looking for the minimum price, but rather for the furthest point or the furthest price from my slope. And we're going to do the same for the maximas. And we're doing this using these two equations here. So I'm measuring at the XX max, the distance between the price, the highest price, and the price that is provided by the slope. And by doing this difference of all these prices, I can extract the maximum distance between the high column values that I've used to find the maximas and the fitting slope that I have found using the polyfit function. Same thing for the minimas. And if we use this procedure, we can run it and plot what we have. This way, things look much cleaner. We have a clear channel. It's an uptrend channel. And those two slopes are defining the margin within which the price is climbing. Again, there is no perfect way of doing this. As you can see, it will strongly depend on what exactly you are looking for, how your strategy would look like, and what you want to use it for. Now, one more consideration that I'm worried about is how many back candles should we consider? Could it be 50, 40, or 30? It depends on the price. The thing is, sometimes you have a channel that would last for weeks. Sometimes you have a channel that would last for a couple of months. And sometimes your channel will be broken within 3 or 4 days. So using a constant number of back candles is not the correct way to do this. To take this into account, we are going to define it a bit more dynamic. We're going to define a range for the back candles. So I'm considering a certain number of back candles. Let's say we have 6 back candles per day because I'm using the 4 hours charts. So if I consider I would like to check my channel of 15 days so far as an average, but then I'm going to define something called B range, like the back candles range. And this is a range where I would allow the program to modify the number of back candles. In other words, imagine I took number of back candles equal to 50, then the B range is equal to 10. So my program is allowed to test different back candles values from 40 up to 60 back candles. And if I take 20, it's going to be 30 up to 70 back candles. And the program will be choosing the situation where I have the most parallel slopes between the minima and the maxima, because this is where we have the most probable situation of a channel, of a trend channel. So the way we are doing this is I have my candle ID, I have my window, which is equal to 3 for the moment. Then I have parameter called optimized back candles, which at the moment is equal to back candles. And we have the slope difference between the maxima slope and the minima slope. So at first I'm putting it equal to 100. It's just a random number. It has to be something larger than what we could achieve. Now for R1, going between back candles minus B range up to back candles plus B range, we're going to define the 4 NumPy arrays, the maxima, the minima, as well as the indexes of minima and maxima. So for each value of back candles that is defined by the R1 variable, we're going to fill these minima and maxima points and their indexes into their respective NumPy arrays. We're going to use the polyfit function once more. And then once we have the slopes of the minima and the maxima, as well as the intercepts, we're going to test the difference, the absolute difference between the slopes of minima and maxima to check if it's less than the slope difference that we currently have, and which was set initially at something that is very big. So now we are going to look for this situation where we have the minimum difference between these two slopes. And the way we are doing this is that every time we're going to test if it's the case, we have this, then we are going to define the new slope difference, which is the new absolute difference between SL minimum and SL maximum. Then we update our optimized back candles number to the current R1 value. And then the slope minima optimized will be equal to the current slope minima. And the slope maxima optimized is equal to the current slope maxima. Then both intercepts are also kept in memory, and we've added the OPT for optimized values of these slopes and intercepts. So again, this optimization will be keeping in memory the parameters defining the situation where we have the most parallel slopes between the minima and the maxima. So we're going to plot our candlesticks, and then we are going also to adjust our intercepts to go through specific points in a way that these two slopes will be wrapping the margin within which the price is moving. So if we plot these slopes on top of our candlesticks, this is what we get for one particular candlestick. And we can see here I've printed the optimized number of back candles. So in this case, it's 46. Remember that this is going to be a result of what we have put here. So we have put 40 back candles plus or minus 10. So it's going to go between 30 and 50 back candles to be tested. The small slicing window width is 6 candles. And we are testing this for the candle ID that is 3000. It's worth mentioning here that sometimes you simply don't have a channel. You don't have a really defined channel that is wrapping the price. It might work very well for some situations. Let's take a different candle ID, for example, 4000, and we can see that it's almost parallel. So the algorithm is trying to find the situation where we have almost parallel slopes. We can also try one more candle ID. Let's check at 5000, for example. Okay, it's not this one. We can check also for candle ID. Let's check for 5000, for example. And here we have another defined channel that is wrapping the price movements. This one looks better anyway. So as you can see, it's not really perfect. It's not like we want it to be, because sometimes we don't really have price channels, but the algorithm nevertheless is trying to find one. So it might not look as clean as we want it to be. The decision is always left to the trader in this case, but we can still try to optimize even more. Let's try something different now. Let's say that instead of looking for the situation where we have parallel slopes, let's check instead for the situation where we have slopes that are the closest to each others. Because sometimes you have big movements of the price, and although you might have parallel slopes, it's completely meaningless because the range defined by the distance between these two slopes is so huge that you wouldn't want to trade in between this channel. It's a big risk, and it's not the optimum situation for a safe trading. So in this case, we are going to repeat exactly the same thing we have done before. And instead of looking for the minimum difference between the slopes that we have used previously, we are going to check for the minimum distance separating those two slopes. So this is the distance as it should be calculated. We have distance equal to the slope of the maximum times the candle ID. So we're considering the distance at the candle ID position plus the intercept max that we have found so far minus the minimum slope times the candle ID plus the intercept of the minimum. So this is the distance separating those two straight lines defining the slopes of the minimas and the maximas. And if the distance is less than my current distance, let's say, I have found a new minimum distance, a new situation where I have a smaller distance. And in this case, I'm going to save the new slopes distance. So this one is from the previous copy and paste. And I will save the optimized back candles number, which is the current R1 value. Then I will also save the optimized slope minima, the optimized slope maxima, and the intercepts, as well as the maximas and the minimas, the points that we have used to fit our slopes of minima and maxima. And then I can plot what we have using, again, an adjusted intercept for the maximas and the minimas. And we can adjust some of the parameters to experiment on. For example, I don't want to give that big choice for the range for the algorithm. I'm going to say we need like 100 back candles on average, plus or minus 50 back candles. And then if we look at the result, we can see that it's almost perfectly wrapping the price movements. It looks cleaner, and we have a clear channel showing around this price. So the slopes are positive, so we have a positive trend. If the slopes were negative, so we have negative trends. So in this case, if you want to add up a strategy on top of this indicator, you might say, okay, I'm going to look for buying positions in this case. And whenever I'm very close to the minima slope and I can see that there is a candlestick pattern, something special like a rejection pattern or a bullish engulfing pattern happening right in this area, very close to the minima slope. In this case, I can enter a buy position, put my stop loss below this slope, and put a take profit twice or 3 times the distance of the stop loss from the buying position. So it's going to be somewhere right here, around here. So yeah, you have small risk, high reward. This is if you want to trade inside of the channel. Some people prefer a different strategy. They detect a channel and they wait when the price breaks out of the channel, either up or down. And this is where they are going to enter the market by selling or buying their positions. If you're curious like me, we can check another candle ID. For example, let's take 15,000, index 15,000. Run this, so we have something for 80 back candles. This is what the algorithm found, and this is how it looks. So I can zoom in and we can see that it is more or less a channel. Remember that we are positioned at this particular ID here and this particular candle here, and this is what we have so far. So this is what the algorithm found. You might want to try to have both, like the most parallel situation of these two slopes, and at the same time the minimum distance. So we can try and put both at the same time. You have to allow this into your program, and we run it again, and we will see what happens. Well, it's almost the same result, so there's nothing much we can do at this point. We can also try a different candle ID one more time. Let's say I don't know, 13 or 12,000. And here we have something. So let me just remove the condition we have just added. I'll stick with the distance on its own. We don't need this line anymore. And yeah, so this is a good algorithm, finding those channels where the price is moving, climbing or going down. And as you can see, it's like a closing triangle here. Okay, one more trial before we end this video. Let's try candle, let's say 10,100. And if we run this, we have 54 back candles, which is the optimum number. And that's what the algorithm found. So let's zoom in and we have something nice. We have a rejection candle here. We have a nice upward trend, and we have a nice we have a price movement within the channel. So we could easily put a buy position at this point with a stop loss somewhere below the minimum slope, and then going up with a take profit twice or 3 times our stop loss value. Okay, thank you very much for staying that long. I think that would be it for this video. I hope you guys found the information helpful. If so, please like and subscribe. It would be of great support for this channel. And as usual, I'm waiting for your comments. Till then, safe trading and see you next time.